Hello everyone, a very warm welcome to our course on network programming and automation with Huawei. First of all, this course is a part of Huawei's Datacom course system. And this course that you are listening to now is also part of a course called Cross-Platform Network Automation launched by 591 Lab. So whether you are looking to complete a certification in the Huawei Datacom series, or just want to learn an overview of Huawei's network programming and automation, or say you are already familiar with Cisco's devices, and you come here to learn about Huawei's devices cross-platform, whatever the reason, as long as you come to this course and follow the progress of this course, you will naturally learn a lot about network programming, automation, and some Huawei-specific knowledge. Okay, so this class will mainly introduce this course and also introduce the concept of what is called a network automation engineer. Well, this refers to the emergence of network automation as a technology or such a field, based on the premise that networks are becoming increasingly complex. We have a lot of network devices, routers, switches, firewalls, and equipment from different manufacturers, especially multi-vendor equipment, that provides you with multiple network management systems, which is actually a very troublesome thing. Actually, I myself have experienced this at a fairly large company where we had a checkpoint system, a management system. So there was this management system and a McAfee system and one from a domestic NAC manufacturer and a Juniper system, even a Sangfa system and a TopSec system and a Elvermeng system and a Cisco system and a Huawei system, etc. Basically, in our team, every day, our job was to log into different platforms for operations, to make configuration adjustments, to implement policies, to search logs, and to finalize some results. In this way, multiple network management systems made our operations very inconvenient. To give a simple example, if there was a small issue in our network application, ultimately the colleagues who handle application development, or those specifically for application deployment, or those dedicated to application operations, they reported back that there might be issues with our network system, or our network security, or our network management, etc. There might be problems within this system, causing various issues with the applications. They even listed the evidence. At that point, we need to investigate. So we need to go through each and every system to investigate, right? So this is a very troublesome matter, especially when the issue indeed turns out to be ours. But by the time we find it, it might take an hour, 2 hours, or even half a day to resolve. In this way, for our modern IT systems, it has a very negative impact. It causes a very bad influence because the delay is indeed too long. Okay, from the day computer networks were created, networks have been complex and difficult to manage. Why are they difficult to manage? Why are they complex? It's because each company has its own network, right? I mean, our corporate systems need to be networked, need to deploy networks, and will not have very many similarities with other companies. That is, there aren't very many commonalities between everyone's systems. So this is reflected in our use of different network devices, right? Even if we use the same type of device, the brands are different. The same brand, different models, the same model, different configurations, etc. So managing devices from different manufacturers, even different configurations of these, and different technological implementation forms, like some use IPsec VPN, while others might use something else, right? Some companies, they use MPLS for some things, and these technical challenges are all different. So this leads to the complexity of network management, different management methods for devices, diversity in network devices, and hence the need for customization, or even using development forms, using programming to create some automation programs. And for example, such automated programs are designed to facilitate automation. Then, for instance, these automated programs. But they may also be divided into various scripts from different manufacturers. But there's a program that summarizes them all and makes integrated calls, and then obtains an integrated result. No matter where the issue arises, or which type of device has the issue, the simplest example is, when it's given to me, after the problem is reported, the log results tell me the alert is the same. Then I find it very comfortable, right? At least the format of the alert is the same, it has a uniform format, so I no longer need to determine based on the alert format which manufacturer's equipment has the problem. Okay, So the evolution of network architecture also affects the factors in current network automation, including the introduction of SDN, software-defined networking. SDN mainly brings a revolution to network architecture because it introduces a network controller, right? It has a controller which operates from a centralized global perspective and controls everything centrally from a global viewpoint. This allows for quick deployment of services, traffic optimization, and even traffic analysis and open network services. These network services are available on a subscription basis. Can these objectives be achieved? Because SDN inherently involves a level of programming, network automation, and network programming have become essential for engineers, both now and in the future. In fact, it's already a recruitable position in many companies abroad. And domestically, recruitment for such positions is also beginning. In the future, it will be an indispensable role. All right, essentially, our network architecture can be divided into, for example, a collaborative application layer. This is where applications run, right? Business collaboration. This refers to network applications. This refers to network applications. To give a simple example, I provide a VPN that allows access to the company's system for operations and then make it available for everyone to apply for. Just like we now use some software to access services beyond the firewall, such as registering and using them in various ways. For example, registration and usage methods and so forth. In my own company, we also implemented a VPN, and even some manufacturers provide such a VPN client, as well as apps for mobile devices, etc. You can easily connect to the company's network securely. Okay, at this time, many people need to register, new employees come, you need to register, and when employees leave, you need to quickly deactivate their access, right? If this layer of VPN that is published externally, if you automate the process of adding or removing personnel, wouldn't it be better than having an engineer manually handle the work order? Here I open it, then another work order comes. Well, this person has resigned. I close it. Of course, this work order might have been created in the morning, and maybe I only receive it at night. It only gets to this step with me. Then I go and close it, but this is too risky, right? In the morning, someone could resign. They might have already left the company, but if they access the company at noon and find the VPN account still works, that's not good, right? Okay, so the control layer will have a certain level of business orchestration. From the perspective of the controller, looking upward is called northbound, looking downward is called southbound. Looking up through the northbound interface can schedule business on the collaborative application layer, and through the southbound, it's easier to reach the device layer. Managing devices, whether it's Cisco, Huawei, it is advisable to use model-driven programming for the southbound interface, and it's generally recommended to use APIs for the northbound interface. Of course, in some ways, these can be interchangeable, right? Okay, so basic network automation involves creating some tools, or even at the most basic level, writing some scripts to automatically complete some tasks. This is the most basic form of network automation, so everyone should start learning now. Basically, by the end of the course, you can definitely do this, and everyone should start with this, because every company's pace of automation is different, and the direction they take is different. So automation in this regard, especially in network automation, it's not like you can handle one company's A's system and then use the same scripts you wrote for company A in company B. That's not possible, right? It's like network configuration. When you come over, you have to change the IP or whatever, right? You can't just start using it directly, okay? So it's a personalized thing. So if everyone starts from the ground up, everyone in the network within their own company starts automating from scratch, it's a very good experience. Our goal is then to gradually reduce dependence on people, meaning less and less human involvement. There are many open source tools in the industry that can help you. Of course, you can choose to use open source tools or choose to write your own tools. Either is possible, because some open source tools might not be able to help you effectively, like Ansible, SaltStack, ProPuppet, Chef, etc. These tools can connect to devices via SSH or other forms to perform batch operation management. For example, Ansible can configure something like what's called a playbook. Inside it, like a stage play, where a group comes up to manage. This wave of commands comes up to manage these devices, and then when it's time for the next group, they come up to manage the next wave of devices. It has a scheduling relationship, but actually, the scheduling relationship, if we write it directly in Python, it can be more flexible, because if you use Ansible to write, you still have to learn its internal syntax, like the Jinja 2 syntax, and then you have to write a lot of templates, which is quite complex. If you write directly in Python, of course, it's more flexible, but with Ansible, the convenient part is because it uses a uniform template form. And these few spaces here, do they mean the same thing? Then, how do you align them with the data above? For a computer, dealing with this kind of data is very difficult. That's why we also have another type of data, called structured data. Structured data is just a moment. Let me draw it. You see, it has a hierarchical sense. It's structured through symbols like this, through these kinds of symbols, to indicate which items are on one level, which are sub-items, and which are auxiliary items, right? In this way, and then in between it's marked with colons to denote like inuti, :20. These two values are then aligned. It's through this structured format that the structured data is then described. Then placed in the netconf protocol, restconf protocol, allowing it to be supported. This way, we can effectively perform network automation. So in our course, we will also learn about this structured data content. And it's also mentioned here that in the early commercial phase of SDN, and for a much longer time in the future, traditional networks and SDN will coexist on a large scale. Because traditional networks can never be completely eliminated. It's like IPv4 and IPv6, right? If you switch to IPv6, IPv4 and IPv6 will coexist for a very long time. IPv4 can't be said to be completely wiped out, not a single one left, cleanly. This is very difficult. Okay, so Huawei introduced something called iMaster NEC, which is often abbreviated as NEC. This is a Huawei company innovation, a kind of network homogenization engine. This is also a key focus of the course, and I believe it will be a key area in the exams as well, right? So we will gradually learn more about it later. From this diagram, you can see the NEC service's openness and programmability includes several modules. There is an automation engine, it has control units, management units, control units, etc. There's also an intent engine for design transformation and verification. For instance, configuration, design transformation and verification, etc. There's also an analytics engine, which includes perception analysis, decision-making, etc. So this is a very vast architecture. How this architecture is used will be explained gradually in the upcoming lessons. Okay, the second point is about the role of a network automation development engineer. What does this emerging position entail? What does a traditional network engineer do? They understand protocols like TCP/IP, understand configuring and managing network devices, right? Understand configuring and managing network devices, okay? And systems engineers? Systems engineers focus on the principles of operating systems, configuring and managing system services like managing systems for Linux, Windows, and middleware management like Nginx, Tomcat, etc. Then, software engineers focus on programming, algorithms, and other relevant development skills like H5 developers or Python Django developers, front-end, back-end, and core algorithms, etc. There are many such skill distinctions. So, network programming and automation corresponds to the role of a network automation development engineer. That's where these distinctions come in, making the position indispensable and specialized. You need to have some of the combined capabilities of the above positions. It is necessary to have some of the integrative abilities of the aforementioned roles. Actually, I have a standard, which is quite simple. That is, if you want to distinguish whether someone is a traditional network engineer or someone who is into network automation, if they can do network automation, just see if they can talk with systems engineers and software developers about these business issues. Discuss systems-related business with systems engineers, and discuss code with software developers on how to write it well. If they have these qualities, because now you will find that many of our top talents, some are, for example, from our client side, leaders in network management, some are technical leaders. They are indeed very impressive. Their ability to engage well with other departments is based on their possession of the knowledge those departments' personnel have, even if it's just a basic understanding, but they are able to converse. That's very impressive. So, such a person essentially possesses the several essential qualities of a network engineer. So you might think about whether you can do the same, like when a systems engineer comes along, you chat with them about Linux systems, for instance, like running a maintenance script. When running multiple maintenance scripts, Perhaps they design some ways to run them, which to run first, which to run next, whether to use coroutines or concurrency. If the discussion moves to concurrency, do I have a calculation of complexity and so on, discuss these matters with them, and see if you can keep up in the conversation. If you are better than them, then you could potentially replace them. Then you can tell the leaders to perhaps let them go. Then you could also talk to the software developers about the things related to development, right? You can then tell the leader to hurry up and dismiss him. Okay, then you can also talk to the developers. Talk about it, mainly about development stuff. For example, during your business development, what aspects are related to networking? Certain parts of its code, for example, are related to networking. Like in its code, are there indeed instances of some specific services polling the server? So, these polling actions, do they use certain specific IP addresses? Should these IP addresses be protected and only allow related machines of the application, or only allow users from the internet to access, first accessing here and then go on to poll, etc.? All these things can be discussed with the developers. Okay? There's nothing much to say about this. This network engineer, the network automation development engineer, has already mentioned they have a certain level of professionalism. So what Huawei offers is there are also some messy things. So I think these things they're not just something that can be simply cultivated like values. You say this thing, it's really hard to talk about, right? If your values align with the company's, that's good. You accept the company's values. That's enough. You don't need to be the same, right? But acceptance is enough. If you think everything your company does is wrong, yet you still help them work, then there's a problem. So things like service awareness, these are hard to talk about. These things aren't emphasized in our course. So here, he just outlined it in blue. The key points everyone needs to master are engineering knowledge, product knowledge, and technical knowledge. Actually, I think from the course, you can learn that it's technical knowledge. What's the use of product knowledge? You need to use it, like always talking about SDN. Have you ever used SDN-related equipment? Right, this is product knowledge. Engineering knowledge is what you need to do. Once you have the equipment, and you also have the relevant technology, you need to create something, right? Okay, so actually, what we can learn here is technical knowledge. You come here to learn technology. That's the basis. Once you have the technology, then you get to know the related products, and then, combining product with technology, you will really understand it. Once you understand, then you go on to do engineering and projects, which is very good. Okay. Therefore, a network automation development engineer needs to possess the skills of a network engineer, system engineer, and developer, combining these capabilities, including but not limited to, firstly, being able to manage source code. But I think this depends on the company. It really depends on the company. This is just what Huawei says. After all, Huawei has an upcoming experiment with Huawei Cloud, a code hosting experiment, right? They want to promote their stuff, but managing source code is actually a very important matter, because it's not just about writing some code like we normally do and uploading it to GitHub. Once uploaded, that's it. When multiple people collaborate on development, this becomes very important. Everyone is writing code, right? Everyone is writing, adding new features, and then two people's features clash. What to do? Revert to one person's previous steps, right? Choose which one, whose code do I merge? This all requires a lot of effort to manage. So, managing source code itself is a very valuable skill to learn. But generally, for this kind of information, let's not even talk about network automation development, even just DevOps development, that is. For engineers currently in DevOps, for those involved in DevOps development, even in big companies, their development teams are not that large. As long as it's development related to operations, like the operations teams in big companies like BAT, operations development teams, compared to the real business development teams, they are much smaller. So in such cases, as long as everyone knows each other and the development isn't too complicated like code management, it's something that can be underestimated, but you can't ignore it. It can be underestimated, but not ignored. Okay, so the next programming language, at least you should master one, right? You should at least master one programming language. Okay, so for our network automation development, it's actually quite different from our system development. Network automation development, the code you develop, doesn't require a very good working environment. That's the truth, meaning the code you develop doesn't need a great working environment. It doesn't require the operational efficiency of your operations code to be very high. Here's a simple example. Let's say I developed a set suitable for Company A, completely free, meaning I didn't charge Company A any money. It's just that maybe the boss of company A is my friend, so I help them develop a set of automation scripts for operations, all conforming to their needs. I'll tell your engineer what automated operations are for. Automated operations are to reduce part of your operational staff. That's the truth. That's what it's for, right? I'm telling you, before you had 3 operation staff, right? Now you can keep just 1. Keep the ones you like, those who you think are smart. Keep them, I'll train them a bit. After training, I'll give them the code. Tell you what to run, maybe run it daily, or set up a cron job or something, run it, keep an eye on your company's systems, keep an eye on the network too. That should be enough, right? If there are changes later, then go make plans. That should work. So I did this. In reality, my operations code, the things it operates, the things it targets, need to be maintained very carefully. For example, it points to our core switch, right? So core switching, once there's a problem, if it's a bit slow, if its working speed is a bit slow, that can lead to big problems. The applications can face major issues. That's not acceptable, right? But the part of operations code I wrote doesn't need to be executed very well. Like the boss of company A, does he think the execution environment of my code is not very good? He gives me 200,000, then buys a bunch of servers, buys some really great servers. Come, you run on these, run your code on these. Comfortable and spacious, right? Isn't it necessary? No need, okay? So this is operations development, and it's different from system development. Because with system development, the system is accessed by users. For example, Meituan, Didi, LA.me, right? If these systems are poorly structured, if their running environments are not good, if they are not spacious or comfortable, then who becomes uncomfortable? The users become uncomfortable. You place an order and it just keeps spinning, then you place an order and it bugs out. What kind of bug? You think it didn't go through, but the vendor received it. They send someone to deliver it. They've made your food already and sent someone to deliver it. They've made your food and sent it out. You think it didn't go through, you check your phone and see the order failed, so you place another order. You place another order, the vendor sees this guy is good, had 1 bowl and wants another, right? So they prepare another bowl for you. And you keep watching on your phone, it hasn't gone through, so you order another bowl. At the time of payment, you see 3 bowls and freak out, right? And then when 3 bowls of food all arrive, you freak out even more, okay? So this is our operations programming and the difference from system programming. Operating systems, we must at least master Linux, Windows, even some basic principles of macOS mechanisms. Some companies, you may need to master mainframes. Some companies, you need to understand mini computers and so on. This differs from company to company. The equipment inside is different. The knowledge of operating systems needed is also different, right? For instance, taking Linux as an example, you should at least master some basic commands. At least you can manage it a bit, and at least on it, you should learn some shell scripting, not only through Python, but you can also write it through shell. Basically, that would be up to standard. Okay, so network technology, this is definitely necessary. If you're a network engineer and don't master network technology, what else would you master, right? Open network architecture, we'll talk about this later. Other professional knowledge, databases, etc. Learn them if you need to. Don't if you don't. Honestly, that's how it is, including algorithms, right? If algorithms are needed, you could use artificial intelligence for operations as well. In our later courses, we include Huawei's HCIE Network Artificial Intelligence. Although at first glance their names sound quite impressive, but I've been following them for almost 2 years now, and the content inside has changed very little, indicating that their development efforts are minimal. So, if they really commit to this area in the future, I believe it could be quite useful. Okay, so that's what this course includes. It corresponds to teaching Git for source code management, teaching Python for programming language. Operating systems are not taught here, but we will have separate courses later that might cover these topics. Huawei has given up on these things, but we cannot give up, right? Network technology, we definitely need to teach that. Everything has to be covered, open network architecture, like these structured languages, and this includes structured language concepts. Then, northbound APIs, business openness, programmability, etc. All these need to be discussed. Other basics like HTTP and the basics of TLS, actually knowing HTTP is sufficient. Tools for northbound calling, etc. are all included in this course. Alright, so our course starts first with the basics of programming, which everyone should have already seen. We've already provided it on UK, which is the Python learning process. So after you finish learning here, within the Python learning process, it's still the first 17 lessons on basics, the core content. I call it core content. After learning the core content, your basic Python knowledge should be pretty solid. If you want to learn advanced topics, then take a look at the next few lessons, those 10 lessons. Then, at that time, it's just about source code management. Next lesson, we will start talking about Git source code management, device openness, and programmability, including these protocols: SSH, SNMP, netconf, restconf, and then everyone is probably familiar with these. All network engineers, these two, if not done with automation, might be unfamiliar, and also telemetry, as well as Huawei device OPS, which is Huawei's. Okay. Northbound openness is just high and mighty. Think of northbound as high and mighty. RESTful is just an API. You click an API on your browser. Of course, you can only access inside, like using Linux's curl command or using our Python's request library, then you can access it. Okay, so business openness and programmability, including things like Jinja 2. Of course, this is also just briefly discussed, how to write this template. The specific deep content could indeed be a course on its own. That's why this subject matter can definitely justify its own dedicated course. Okay? And writing Huawei's network source driver packages, writing business packages, and integrating new devices with iMaster's AEC, and building new business practices. We will discuss these in the course. Okay, so device openness and programmability actually involves writing good code and then deploying it to the devices through these mechanisms. It's as simple as that, then extracting things from the device and running them back through your code. It's really about the code interacting with the devices. Before, it was us humans interacting with the devices. We type a command, it executes below, right? Collect IP, whatever, okay? Display whatever, and so on. Basically, just typing commands. It was all commands before, okay? Now we just run Python time, and that's enough, okay? So northbound openness involves controllers, getting all the content out. Of course, you can manage without controllers too, right? It's not a must to have controllers. Business openness and programmability also include a business package. Inside, there is a style and well-written templates, right? Jinja 2 is used to write templates. Python is used to write business callback logic. Style itself is a language used to write style models. Then, after it's packaged, it becomes what's called a network source driver package. Okay, so let's just summarize briefly. Our course is based on Python fundamentals. You're already familiar with it. If you're still not familiar with Python basics, you should at least review them before starting the course. At least take a look, review them, or write some code yourself. If you are already proficient in Python basics, just join our course directly. If you've completed our Cisco DevNet Associate course, you're also welcome to join our course. Then, at this time, you can compare Cisco's products with Huawei's products. Our course will also compare devices from various aspects, seeing what's the same and what's different. Once you clarify this, our automation work will be much easier. Okay, so that's it for this session of the course. Okay, thanks everyone.